Hey guys, welcome back. Today we're going to be working on a problem that asks you to find the PMF of a function of a random variable. So let's just jump right in. The problem statement gives you the PMF for a random variable called x. So we're told that there's this random variable x that takes on values -3, -2, -1, 1, 2, and 3. And for each of those values, the probability mass lying over that value is given by this formula, x squared over a. Now, I didn't write it here to save room, but we're also told that a is a real number that is greater than 0. And we're told that the probability of x taking on any value outside of this set is 0. Now, we're asked to do two things in the problem. First is to find the value of the parameter a. And that's sort of a natural question to ask, because if you think about it, sort of the PMF isn't fully specified. And in fact, if you sort of plug in the wrong number for a, you actually won't get a valid PMF. So we'll explore that idea in the first part. And then in the second part, you're given a new random variable called z, and z happens to be a function of x. In fact, it's equal to x squared, and then you're asked to compute that PMF. So this problem is, it's a good practice problem. I think at this point you guys are sort of newly acquainted with the idea of a PMF, or probability mass function. So this problem will hopefully help you get more familiar with that concept and how to manipulate PMFs. And by the way, just to make sure we're all on the same page, what does a PMF really tell you? So P sub x, where this is a capital X, because the convention in this class is to use capital letters for random variables. So Px of k, this is defined to be the probability that your random variable x takes on a value of k. So essentially this says, and this is just some number. So in our particular case, this would be equal to k squared over a. And how you can interpret this is this Px guy is sort of like a machine. He takes in some value that your random variable could take on, and then he spits out the amount of probability mass lying over that value. Okay, so now that we've done that quick recap, let's get back to the first part of the problem. So we have this formula for Px of x, and we need to solve for a. So in order to do that, we're going to use one of our axioms of probability to set up an equation, and then we can solve precisely for a. So namely, we know that every PMF must sum to 1. And so essentially, if you sum this guy over all possible values of x, you should get a 1, and that equation will let us solve for a. So let's do that. Summation over x of Px of x. So here, essentially, you're only summing over these 6 values. So this is equal to Px of -3 plus Px of -2 plus Px of -1, etc. Px of 2 plus Px of 3. Okay, and again, like the interpretation as we said, this sort of number here should be interpreted as the amount of probability mass lying over -3. And to help you visualize this, actually, before we go further with the computation, let's actually plot this PMF. So the amount of probability mass lying over -3, the way we figure that out is we take -3 and we plug it into this formula up here. So you get 9 over a. Now you can do this for -2. You get 4 over a looking at the formula. For 1, you get 1 over a. And of course, this graph, it's the mirror image over 0 because of the symmetry. So hopefully this little visualization helps you understand what I'm talking about. And now we can just read these values off of the plot we just made. So we know px of minus 3 is equal to px of 3. So we can go ahead and just take 2 times 9 over a. Similarly, we get 2 times 4 over a, and then plus 2 times 1 over a. So now it's just a question of algebra. So simplifying this, you're going to get 18 plus 8 plus 2 divided by a. And this gives you 28 over a. And as I argued before, you know that if you sum a PMF over all possible values, you must get 1. So this is equal to 1, which of course implies that a is equal to 28. So what we've shown here is that you actually don't have a choice for what value a can take on. It must take on 28. And in fact, if you plug in any other value than 28 in here, you actually are not going to have a valid PMF because it's not going to sum to 1. Okay, so I'm going to write my answer here and then erase to give myself more room for part B. So part B is a little bit more involved than part A because we have a function of a random variable. But, okay, so we are told z is a new random variable, and he's equal to x squared. And as you probably know already, this is sort of a valid thing to do. X is a random variable, and any function of a random variable is itself a random variable, so therefore z is a random variable. And because z is just another random variable, it makes sense to talk about its PMF, or its probability mass function. So we are asked to figure out what pz of z is. And again, the notation, this sort of notation can take a while to get used to, but always just come back to the basic definition. And let's switch this to a k so we don't get confused. So this z is a capital Z because it's a random variable, and this k is a little k because it's just denoting one possible value that your random variable z could take on. So coming to the definition of PMF, pz of k is just the probability that our new random variable z takes on a value of k. Okay, and you could sort of progress from here and do this algebraically, but I would prefer to look at this problem pictorially. So the first step that I suggest we take is we figure out what are the possible values that z could take on. So for instance, for our PMF of x, we were told that x can take on values in this set. So I think a good place to start is figuring out what is the set of values that z can take on. So let's think about this a little bit. I'm going to go up here. So z takes on values in what set? Well, when x is equal to minus 3, z takes on a value of 9, right? Because minus 3 squared is 9. So that's one possible value of z. Because since z is a function of x, the possible values of x influence what values z can take on. Now when x takes on a value of minus 2, z takes on a value of 4. Similarly, when x takes on a value of minus 1, z takes on a value of 1. Now, when x takes on a value of 1, z takes on a value of 1, and we actually already have 1 in our set. Similarly, 2 squared is 4 and 3 squared is 9, but we already have those guys in our set, so we're actually done. Z can only take on one of these three values, 9, 4, or 1. So now, let's come down and sort of plot a new picture. So before, on this axis, I was plotting the value that the random variable x takes on. Now I'm going to plot the values that the random variable z can take on. So z can take on, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me just number these really quickly. Okay, So z can take on a value of 1, it can take on a value of 4, and it can take on a value of 9. And as we argued before, these 3 points are the only ones that should have any probability mass over it. Okay, so now let's think to ourselves, when, or sort of how frequently, does z take on each of these 3 values? Well, z takes on a value of 1 precisely when x takes on a value of -1 or 1. Take a moment to sort of convince yourself of that. There's no other scenario under which z can take on a value of 1. Now, x takes on a value of -1 with probability 1 over a, and x takes on a value of 1 with probability 1 over a. And so z, therefore, would take on a value of 1 with probability 2 over a. Now, I've sort of been appealing to your intuition, but if you wanted to sort of say in math what I've been saying, I was claiming that the event that z takes on a value of 1 is equal to the event that x takes on a value of -1, or x takes on a value of 1. And now, clearly, these 2 events are disjoint. X can't both simultaneously be 1 and -1. So from this, if you were to take the probability, you would get the probability that z is equal to 1 is just the sum of these 2 probabilities. And they both have value 1 over a, so we get 2 over a. So let's come over here and do 2 over a. So now let's take a look at the next value. So what's the probability that z takes on a value of 4? Well, it's very similar logic. Z can only take on the value of 4 if x takes on a value of -2 or if x takes on a value of 2. And x takes on a value of -2 or 2 with probability 4 over a plus 4 over a, which is 8 over a. And I'll actually just sort of do this logic out one more time. So we have the event that z is equal to 4 is the event that x is equal to -2 or x is equal to 2. These 2 events are disjoint, so to compute the probability, it's just the sum of these 2 events, the probabilities of those events. And we know that the probability that x takes on a value of -2 is 4 over a. And similarly, the probability that x takes on a value of +2 is 4 over a, so you get 8 over a. And now I won't repeat out sort of the math for our last candidate, but sort of same argument, z takes on a value of 9 when x takes on a value of -3 or 3, so you add 9 over a and 9 over a, and you get 18 over a. Mind you, my picture is not to scale. So we're essentially done because we already computed the value of the parameter a in part A. So now I just want to write this out in a clean form, because we've mainly been drawing the PMF pictorially, but you should be comfortable with both representations. So to actually represent the PMF of z algebraically, you would say that Pz of k is equal to 2 over a, so a was 28, right? So 2 over 28 for k equal to 1. 8 over 28 for k is equal to 4, and 18 over 28 for k is equal to 9. And let's just do a quick, and sorry, this is not complete. You should always specify 0 otherwise, right? Because if I didn't say that, then there would be a chance that this didn't sum to 1 and you wouldn't actually have a valid PMF. So let's just do a quick sanity check. Before we had argued that z can only take on 3 values. So here we have z can only take on 3 values, 1, 4, or 9, so that's consistent. And then another sanity check you should make is that these in fact do sum to 1, and you see pretty quickly that they do. 2 plus 8 plus 18 is 28. So looks like we did it right, and then of course you can simplify these, but I'm not going to bother to do that now. So the hope is that after having done this problem, you feel more comfortable with what it means to be a PMF and how to manipulate them. So if you have a random variable, which is sort of a simple function of another random variable, you should be comfortable computing the PMF of the new random variable. So that's it for today. See you next time.